3 topics. Let's start with key concept 18 that talks about different states of matter. Mainly we know that we have solid, liquid, and gas. They have different arrangement, different speed of motion, different properties based on the arrangement of particles in each state. Number 2, we need to cover the idea of Brownian motion, like ability or description of particles, gas particles, when or fluid particles, not just gas, solid, liquid and gas particles, when they collide and move in random direction, forming a zigzag motion. Starting with question 1 here. Which law describes the arrangement and the motion of molecules in gas? So gas, which means free motion, and the arrangement are far away from each other. So the option that matches the description is A. Going to, what is the correct particle diagram for solid? We know that solids are very close to each other, tiny spaces between particles, so obviously B. Which law describes the forces between the molecules and the motion of the molecules in solid? We know force between particles is very strong. Motion is vibration. It vibrates in its position because we're not able to use, it's not in motion, so it is moving but in a vibrational way. Going to which law describes the force between the molecules and the motion, but in case of gas is completely opposite to solid. Gas, regarding forces between particles, is very weak. Regarding the motion, of course, it moves freely, randomly, in all directions. Next, here we have description or statement, and you need to check, does it describe solid or gas? Molecules are closely packed, of course, this for solid. These parts are like so easy, straightforward. Molecules are free to move around from place to place, of course this is for gas. Molecules are far apart, automatically gas. Molecules can only vibrate in a fixed position, solids. Molecule change position randomly, this for gas as well. So mainly these questions are describing in a straightforward way main properties of solid, liquid, and gas. So it's easy, straightforward. Now going to the new part or the additional part that talks about Brownian motion. What does it mean? What does it describe? How it describes the motion of fluid particles? As we agreed before, this type of motion, it describes when gas or liquid particles are found among other particles due to the collision between, for example, in case of pollen grain here, pollen grain, these big particles are found among water particles. So due to the collision between these water particles with pollen grains, let me draw them, these are pollen grains and these are water particles. Due to the collision, this will allow pollen grains to move in a random and zigzag motion known as Brownian motion. So what are the moving specks of light here? This is a description for an experiment. Very small pollen grains are suspended in water. A bright light shines from the side. When looked at through a microscope, small specks of light are seen to be moving in random, jerky manner. So what do you think the main reason of this? that is pollen grains hit by water molecules. You don't ever think it's a collision between pollen grains with pollen grains. Wrong. It's not a collision between water molecule with water molecule. Also wrong. It's collision between pollen grains with water molecules, that these grains, pollen grains, hit by water molecules. Here, going to next part, question 8, that talks about the same concept here. But in this situation we have smoke, big particles in air, among air particles. So again, these are air particles. We have here smoke or big gases, again as if these are pollen grains. So due to the collision between these smoke particles with air particles, also this will cause smoke to move randomly in all directions. Same description. So smoke particles move randomly due to the collision between these smoke particles with air molecules. Which is the best diagram represents the movement of smoke particles in Brownian motion? It doesn't show straight, it shows zigzag motion, and this zigzag like as a straight line with zigzag around them. It's not curvy. These curves wrong. It's not curvy, so it's just D. Again here, some gas in a scaled plastic bag is cooled. How do the gas molecules behave when this happens? These questions are describing changes, the state of matter from solid, liquid, and gas. So as we know, we have different states. Let me show you states of matter. Changing the state of matter. Change of state of matter. While due to these changes, when solid changes to liquid or liquid to gas, we call it as processes of changing state of matter. When particles are getting changed from state to another state, temperature doesn't change. Just energy is added or removed. So in melting, evaporation, in these two processes, energy is added, while condensation, freezing, energy is removed, but temperature doesn't change. Constant temperature.